that the atmosphere can hold. Next term. Term you're all familiar with, you've heard several times, I'm sure, humidity. Very simply put, water vapor in the atmosphere, or water vapor in the air. That's humidity. Is it humid today? Yes, very. It's raining off and on. We're probably going to get rain again today. So the humidity, or the water vapor in the air, is fairly high. What's one characteristic about humidity? What's humidity usually do?
Flattens your hair.
Okay. Those girls just hate it when their hair gets flat. Other thing, go outside and would you rather be outside working in the yard on a day that's 90 degrees and very humid, or a day that's 90 degrees and not very? Okay. It's sticky, muggy, it's not very comfortable. Sweat usually a lot more easily on humid days. There's a lot more moisture. Next one. Term that you should see on the news or hear on a regular basis, relative humidity. The measure of the amount of water vapor actually in the air compared with the maximum amount that the air can hold at a certain temperature. Measure of the amount of water vapor actually in the air compared with the maximum that the air can hold at a certain temperature. Now, when you look at air, this is the property we need to discuss. Air is made of gas molecules, whether that's oxygen or carbon dioxide or nitrogen. There are many gases you can put in. What you have to know is about the particles in the air, or the molecules in the air, at different temperatures. Example of this. Doing dishes. What water usually works better to clean dishes? Cold water or hot water? Why does hot water work better than cold water? What's happening to those water molecules in hot water versus cold water? It has to do with speed. What? They move faster. They're moving faster. So they're more active to get whatever you're trying to get off that plate or get it clean. If you take two sets of water molecules, one moving very slow, one moving very quickly, the ones moving quickly have more space between the molecules. The cold ones are usually kind of bunched up. The warm ones are just all over the place. They've got all this space between them. Now, if you look at air molecules, they're the same way. The warmer the air, the faster those air molecules are moving, and the more space there is between the air molecules. If there's more space between the air molecules, what does that mean that you can put in those spaces? Adam?
Oh, water vapor.
Water vapor. Right. The warmer the air, the more space it has to store water vapor. Air that is 90 degrees can hold a lot more water vapor than air that is 50 degrees, because there's more space between the particles. Now, with relative humidity, what this is telling us is we're measuring how much moisture is in the air at that time compared to how much that air could really hold. Example, if I have this is my box of air. Okay, this box of air is 80 degrees. And I have a little chart that some weather guy has told me that in this chart, or on this chart, it says that if I have this box of air at 80 degrees, it will hold 10 milliliters of water. At 80 degrees, this box will hold 10 milliliters of water. Now, and I measure it, and I find out that there are only 5 milliliters of water in this box of air that I've got. What? And then the relative humidity. What's that? Why is it 50? Okay. It can hold 10 milliliters total. And currently the air is holding 5 milliliters total. That This is basically a simple version of a psychrometer, the one I whipped up yesterday. Very simple. All it's got, two thermometers. These thermometers are exactly the same. They both read in Celsius. I just took them, mounted them to a piece of, like a file folder, two pieces of foam, cut little notches in it, ran them across there. What's the main difference between the two, though, is this. On one part of the thermometer, I took a bunch of this filter wool, or cotton basically, and wrapped it around there, and then connected it with some rubber bands. These are called bulbs of the thermometer, the silver parts down here on the bottom. What they do to measure relative humidity is they take these two, and they take this bulb here, and they get it wet. This is the wet bulb, this is the dry bulb. This one stays dry. They read the two, they will come up with different temperature readings. Then you do a little formula, which is really easy, I'll show you in just a bit. You come up with the relative humidity, or actually what the humidity is in the air compared to how much you can actually hold. That's the psychrometer. We'll look at that a little more in a bit. Next one, absolute humidity. This is pretty simple. Basically, it's to measure the amount of water vapor that's in the air at a certain time. Or I guess that's up there. Measure the amount of water vapor that the air contains at any given time and place. So that's a measure of how much moisture is in the air. This is not concerned with temperature. This is not concerned with how much water or water vapor that air can hold at that time. But just at that point, how much moisture or water vapor is currently trapped in the atmosphere. That's absolute humidity. Difference between absolute and relative humidity. To determine relative humidity, you have to know the temperature. You have to know how much moisture can actually be held in that air at that point. And then you have to have a psychrometer or something to tell what the current rate of evaporation is with temperature and what the rate of temperature. Got this? Question so far that you have? None? We got just one or two more. There you go. Psychrometer. That's what I just showed you. Tool used to measure relative humidity, and it's composed of a wet and a dry bulb thermometer. Not very difficult to make a wet bulb thermometer. Wrap a piece of cotton around it, dip it in some water, presto, change to a wet bulb thermometer. We actually have two more to cover. Next one, dew point. This is the one that Curtis was talking about when he gave us an example of condensation. You're looking at the temperature at which condensation occurs. If the dew point is below 0 degrees Celsius, then you have frost. I was watching the news last night. They said the low last night was supposed to be like 60 or 66 degrees, and the dew point was 48. That meant that if it got down to 48 degrees or 47 degrees or whatever last night, and I went tiptoeing through the tulips this morning, I would have gotten my shoes wet or my toes or whatever. That's the dew point. In Fahrenheit, what's the same thing as 0 degrees Celsius? 0 degrees Celsius is